the next step is to draw or represent the vectors v4 and v2. v4 is the velocity vector at t4. So the application point of the vector is m4. The vector is drawn tangent to the trajectory in the way that we can join m3 and 5 and draw it parallel to m3 and 5. The length of the vector can be obtained by certain calculations, either by determining v4, which is approximately equal to v3 5, which is equal to m3 and 5 over delta t, and by measuring the length m3 and 5 divided by delta t, we can obtain the length of the vector v4, or from the magnitude of the velocity vector. Okay, with a certain scale we can determine the length of the vector حسب شو نحنا معنا بالجبن. Now v2, in the same way we represent the vector v2 by joining m1 m3. The length of the vector m1 m3 gives the length of the distance m1 m3. From the distance m1 m3 we can obtain the length of the vector v2. Next step, we have to translate the vector v4 to m3. Since we have delta v24, to construct delta v24, it is the addition of the two vectors v4 and minus v2. So we translate v4 to m3s. It will be along m3 and 5. then v4 to m3 ناخده نفس الطول parallel to v4, and since v4 parallel to m3 and 5, it will be along m3 and 5. So this is v4 at m3. Then we have to draw minus v2. We translate v2 in the opposite sense to obtain minus v2 parallel to v2 and this in the opposite sense, and this, with the same length. Then delta v will be the sum of the two vectors v4 and minus v2. It will be m3 and this point, the end of the vector minus v2. This is delta v24. So along delta v24 we can represent the acceleration a3. The length of the acceleration vector a3 أكيد can be determined by certain calculations according to the given, and we can use certain scale كمان حسب شو ممكن يكون معنا given in the problem.